It is a section 1.2 Matlab, a powerful computer language. Matlab stands for Metric Laboratory. Matlab is a multi-paradigm numerical computing environment and a proprietary programming language developed by MathWorks. It is not free. However, it is quite flexible, and you can do also some symbolic computations, and it is easy to learn and easy to use. Along with the Matlab, you can do metric manipulations, plotting of functions and data, and also you can implement algorithms, and you can create user interfaces, and also you can call some other languages such as C, C++, C#, Java, Fortran, and Python. And particularly, Matlab is very good at metric manipulations. And also, you can do computer algebra. That means that you can do some symbolic computation. And we can say that Matlab is about most convenient computer language to learn and to use as well. For each of the programming languages, there are 4 essential components to learn. The first one is looping, and that deals with repetition. And second one is conditional statements, dealing with cases. And also, you have to learn how to make input and output. And finally, you have to make modularization and save the functions into functions so that you can use later on for similar projects. So that is about reusability, and also in this way you can finish implementation very effectively. Okay. Here, introduction to Matlab or Octave. Octave is an alternative to Matlab. It is free, and the Matlab programs can be run in Octave in most cases without any modification. They are not exactly the same. However, in most cases, in your level, it'll work. Okay. Here, vectors and matrices. The most basic thing you'll need to do is enter vectors and matrices. And if you use the command, the window in Matlab, then you'll see such prompt. And okay, let's see Octave. Okay, this is Octave window, and you see here the prompt. Here you can give some command. For example, now we try to define a metric. Okay, that is 1 and 2, and in the second row it is 3 and 4. Then you can see the result. A is this metric. Okay, in this way you can define, and roots are separated by semicolon or enter, new line, and or entries in a row are separated by commas or space. Okay, we'll see the detail here. 1, 2, 3 along with the commas, then because it's new row, so that it'll be a vertical vector. So it's a column vector. Okay. Now the W is 5, 6, 7, 8, and just we separate it. There is no row, new row, so that it is a row vector. And now 2, 1, semicolon, 1, 2, then along with this semicolon, it will make a new row so that it will become a matrix. And either space or comma can be used so that this one and that one will produce the same matrix. The symbols, the comma and semicolon, can be used to combine more than one command in the same line. And if we use a semicolon, Matlab sets the variable but does not print the output. If we are using semicolon at the end of the command, then it is happening. Here we have P is 2, -3, and 1. That will make a column vector, and also it makes a column vector. However, the comma is indicating we have 2 commands, but for the second one, here, along with this semicolon, it is executed quietly so that the output is only about P. Q is also defined, but it's done quietly. Now P plus Q, so you can easily see that now P plus Q is the desired output. So compute wisely, it is added. 2 plus 2 is 4, and -3 plus 0 is -3, and 1 plus -3 is -2. Okay, also here, now that dot product between P and Q is computed and saved into D, but because of the semicolon, it's done quietly. Okay. Instead of entering a matrix at once, we can build it up from either its rows or its columns. You can build a matrix and part by part. Okay, here C1, C2 are vertical vectors, the column vectors, and these 2 column vectors are combined to make a matrix. C1 is 1 and 2, one column, and C2 is 34, another column, and we combined them to make a matrix. Now C3 is another column. We can combine behind here the original matrix M, so that M is now expanded in this way. Okay, here C4 is defined as to be C1, and then now we defined a row having 4 components, so that now we try to add behind M in C4, which will be C1, so that this result will make these first 2 rows, and then now at the bottom we are adding one more row from R3, so that we can get it in this way. So now we use another notation, so that N becomes this 3 by 4 matrix. Okay, in this way, matrix can be built part by part. Okay. Here we have operations with vectors and matrices. Matlab uses the symbol multiplication sign for both scalar multiplication and matrix vector multiplication. In Matlab, we can access the ijth entry of a matrix by typing Mij. if you want to retrieve more than one element at a time, then you can give a list of columns and rows that you want. For example, 2 to 4 is same as 2, 3, 4. And if you use just colon, and then that means all. So here MI colon, then in vertical direction is ith one, but horizontal direction there is all of the row, so that this means the ith row of a matrix M. Similarly, M colon J means the jth column of M. Okay, we first define here the matrix M, and now we try to access 2, 3. Then second row, third position, it must be 7. Now here for that one, third row, and inside of bracket we choose 2 and 4. That means here third row and second one and fourth one. So the 10 and 12 must be the answer. Now for this one, now everything and the second column, which means that one 2, 6, 10, that must be output. Now this is a vertical vector, so it's a column vector, and times 3. Then for each component 3 is multiplied, and MV, that is this matrix times the vector, then you can see here the answer. Okay. To multiply two matrices in Matlab, also we can use symbol here, asterisk. The n by n identity matrix is formed with the command IN. That will make n by n identity matrix. The diagonal, main diagonal is 1, and off diagonal entries will be 0. You can ask Matlab for its reasoning and using the command Y, but unfortunately Matlab very often takes the attitude n gives a random response, so it is quite funny. Okay, here A is 2 by 2 matrix, and B is again 2 by 2 matrix, and here A times B can be made. Now I is I 3, so it's a 3 by 3 identity matrix. Now C is again another 3 by 3 matrix, and we can make inverse of this matrix by using command inverse. And here that must be same as here now I, and that means C inverse times I, so that eventually C inverse 2 and C inverse must be the same. They are practically the same. If we multiply C inverse to C, then must be identity matrix, right? Okay. Now graphics with Matlab. In Matlab, the most popular graphic command is plot, which creates a 2D line plot of theta in y versus the corresponding values in x. So here, the plot command must be given in this way, and plot and x1, y1, and line spec and xn, yn. So you can plot n separate curves. So that is a typical format of using plot. Okay. Here, for this one. Okay, let's go to Octave, and here, okay, in this directory, I guess, okay, let's see, the name is figplot.m. Okay, let's see if we have that. Okay, there here, figplot.m. Then you can see here now, close all. So once you are running this program again, then you may have many plot open. Along with close all, you can destroy all figures open. Then you can make newly through this command. Now there is x1 is the points, and n is 11. That means from 0 to 2 pi, we are choosing 11 points, and the first point will be 0, and last point is 2 pi, so that we have 10 subintervals equally spaced. And y1 is cosine x1, so that now y1 is cosine values of these 11 points. And we can make another curve by using now 51 points, and now second one will be a sine curve, so that here we want to plot and x1, y1, that is cosine curve, and there's a line spec, and there is a solid, and O means try to add a mark O, and R means red, and line width must be 2, and x2, y2, which is for sine curve, and there's solid and blue, and line width is 2, and we are trying to add the legend, and axis must be tight, and okay, and the figure can be saved in this file. Okay, here we can execute by clicking run here now, saving file and run, which is same as F5, so that here from and here now I hit F5, then it is executed, and you can see the figure coming out. Okay, it is executed, and also you can check the execution from command window. Here figure plot is executed, and you saw the figure. Okay, now okay, so I put the figure here. Okay, I explained already about the operations over there. Okay, now in Matlab, and for contour plots, you may use here contour, the command contour, and for figuring 3D objects, you may try surf and mesh. Once the function is given rather than data, in this case, we are making data here. Now, x1 and y1, so there is discrete points, and we make here data, but we may use cosine x directly. So if you are using function and try to make a plot in 3D or 2D or 3D, you can use here along with F in front of the command, F plot, then that means a function plot, and F surf and F mesh, and 3D plots will be produced. The Matlab is quite powerful and well documented as well. So by using either help or DA, you can see what it is, and you can get the information. Let's go to here now command window, and if you give here help and plot, then you'll see such output, and it is explaining how to use plot command, so that this is typical example, and now it is explaining all the way about the specs, and you can choose from this one, and then here you can get the desirable plots. Okay. Okay. That's the first part, and we'll continue in the second part. Thank you.